At 09:17 a.m. on September 6, 1941, over the Boeing assembly line in Seattle, Washington, the clang of hammers on steel echoes through Plant 2. Rivets are driven into B-17 wing sections at a rate 30% below War Department projections. The crew's tired eyes dart across the factory floor, but one figure stands apart. Ruth, the lead riveter. She holds the pattern in her hand like a map, feeling every curve and angle the engineers have marked. Around her, others rush to replicate the shape, imperfectly, no matter how many times they try. A frustrated shout rings out. Another wing section falls behind schedule. But Ruth doesn't let the pressure show. She adjusts her goggles and locks the template in place. A single rivet, then two. A third. Precision. No hesitation. This is her impossible pattern, designed to fit geometries no one thought producible. The clock keeps ticking. One wrong move, and the entire line grinds to a halt. Failure isn't an option. On September 6, 1941, in Seattle, Washington, Boeing's Plant 2 hummed with the sound of American industrial mobilization. Inside the sprawling complex covering 31 acres, riveters, engineers, and assemblers moved like clockwork, united by one goal: to build B-17 flying fortresses faster than the contract required. The War Department had ordered 500 B-17Es by year's end. Boeing was behind by 47 airframes. Ruth Erickson, employee number 4127, stood by the new wing assembly jig, wiping sweat from her forehead as she secured another section. The blueprint before her showed compound curves that required 12 rivet lines converging at angles between 17 and 23 degrees. Most workers could manage straight-line patterns. This one demanded something different. Ruth had become essential to the line, her hands steady even as pressure mounted across 3 shifts. In the months leading to this September morning, aircraft production had lagged behind Army Air Corps projections by 22%. Now it was a race against time and geometry. The B-17E featured redesigned empennage and increased defensive armament, 15 modifications from the D model. Each change added complexity to assembly. "Keep the pattern tight, Ruth," Foreman James Holbrook called across the noise. She nodded silently, aware of the stakes. Every minute counted. These aircraft would be the backbone of American strategic bombing doctrine. Their strength measured in altitude, payload, and survival rates over Europe. She locked eyes with Thomas Chen, a riveter who'd transferred from the Navy Yard. There was admiration mixed with apprehension in his gaze, apprehension about the tempo, about the precision required. Ruth knew the feeling well, but she couldn't afford to show it. The pressure was identical for everyone. For her, though, failure could cascade through the entire assembly sequence. Records from Boeing's production office, preserved in the company archives, show that winged Assembly Station 7 averaged 4.2 completed sections per shift in early September. The target was 7. Ruth Station was logging 6.8. On September 6, 1941, in Seattle, Washington, Boeing's Plant 2 hummed with the sound of American industrial mobilization. Inside the sprawling complex covering 31 acres, riveters, engineers, and assemblers moved like clockwork, united by one goal: to build B-17 flying fortresses faster than the contract required. The War Department had ordered 500 B-17Es by year's end. Boeing was behind by 47 airframes. Ruth Erickson, employee number 4127, stood by the new wing assembly jig, wiping sweat from her forehead as she secured another section. The blueprint before her showed compound curves that required 12 rivet lines, converging at angles between 17 and 23 degrees. Most workers could manage straight-line patterns. This one demanded something different. Ruth had become essential to the line, her hands steady, even as pressure mounted across 3 shifts. In the months leading to this September morning, aircraft production had lagged behind Army Air Corps projections by 22%. Now it was a race against time and geometry. The B-17E featured redesigned empennage and increased defensive armament, 15 modifications from the D model. Each change added complexity to assembly. "Keep the pattern tight, Ruth," Foreman James Holbrook called across the noise. She nodded silently, aware of the stakes. Every minute counted. These aircraft would be the backbone of American strategic bombing doctrine, their strength measured in altitude, payload, and survival rates over Europe. She locked eyes with Thomas Chen, a riveter who'd transferred from the Navy Yard. There was admiration mixed with apprehension in his gaze. Apprehension about the tempo, about the precision required. Ruth knew the feeling well, but she couldn't afford to show it. The pressure was identical for everyone. For her, though, failure could cascade through the entire assembly sequence. Records from Boeing's production office, preserved in the company archives, show that Wing Assembly Station 7 averaged 4.2 completed sections per shift in early September. The target was 7. Ruth's station was logging 6.8. On September 8, 1941, Ruth huddled over her bench at Station 7, inspecting the wing section before her. There was a fleeting moment of doubt as she checked the rivet pattern against the engineering drawing. Something didn't align. "I think the wing's off spec," Mechanic Harold Voss muttered beside her, eyeing the incomplete section. His hands fidgeted with a rivet set. Ruth didn't need to be told twice. She'd seen how quickly small deviations snowballed into rejected assemblies and lost shifts. She picked up her calipers, a Brown and Sharp model standard across Boeing's tool cribs, and measured again. The tolerance was plus or minus 3/32 of an inch. She was reading too, 30 seconds high on the forward spar attachment. Her mind raced through the past 2 weeks. The design changes issued September 1st, the short tempers, the mounting pressure to hit War Department deadlines. There was no room for error. Army Air Corps inspectors walked the floor daily, clipboards in hand, red stamps ready. Ruth tightened the jig clamps, adjusted the template, and recalculated the rivet spacing. The math was simple. 12 rivets across 17 inches meant spacing of 1.42 inches center to center, but the curve added complexity. Each rivet had to seat perpendicular to the skin, not perpendicular to the floor. "Got it," Ruth muttered, more to herself than anyone else. She reset the pneumatic gun, checked air pressure, 90 pounds per square inch, and began again. 3 minutes later the section passed. But as she returned to the rhythm of work, the clock above Station 7 ticked louder in her awareness. Her pattern might work, but time was finite. Holbrook had mentioned that morning. Another delivery deadline, October 1st, 23 days away. 52 airframes due. Ruth did the math in her head. 2.26 aircraft per day. Every day, no exceptions. The factory was currently averaging 1.8. On September 10th, 1941, the factory was alive with second shift activity, but Ruth's mind tracked a different rhythm. Every 20 minutes she was interrupted by workers attempting to replicate her wing pattern on adjacent stations. They fell short. Time and again, the compound curves didn't align. Rivets seated at improper angles, weakening shear strength. Workers around her grew frustrated, voices rising above the pneumatic hammering. Ruth pushed through. Her hands were raw from the vibration of the rivet gun, the constant pressure against her palms. She didn't stop. The hum of the assembly line, 200 rivet guns firing in irregular percussion, was deafening. Ruth's focus sharpened. She'd been refining this pattern for 3 weeks, ever since the jig was installed. It wasn't just a task. It was personal. She'd seen the way some of the men looked at her when she first arrived in May. Like her work, like her presence, was temporary. But not today. Today Ruth was determined to prove that precision trumped skepticism. She watched the progress of the workers beside her, the ones who'd doubted her initially, and felt quiet pride. Every section she completed was another piece of the war effort. She was no longer just part of the machine. She was an essential gear. Station 7's log, maintained by shift supervisors and preserved in Boeing's Industrial Relations archive, shows Ruth Erickson's output. 7 wing sections completed on September 10th, exceeding the target for the first time. The notation reads, Station 7, full spec, 0 rejects. But as the shift wore on, Ruth knew the factory's overall rate remained far below requirement. Plant 2 was producing 43 major assemblies per week. The contract called for 62. This gap could mean delays in bomber deployment, delays that translated to vulnerabilities in the Atlantic and Pacific. Ruth understood this not from briefings but from the tension in Holbrook's voice, the urgency in every memo posted on the bulletin board near the time clock. On September 15, 1941, a loud clang echoed across the factory floor at 2:47 p.m., cutting through the normal cacophony of industrial production. Ruth's heart skipped as she looked up from Station 7. 30 feet down the line, one of the wing sections had been mishandled during transfer from jig to transport dolly. The rivets along the aft spar hadn't seated correctly. Pneumatic pressure had been insufficient. Panic swept through the assembly team. "Fix it now," Holbrook snapped, his voice sharp with urgency that everyone felt. Rejected assemblies meant disassembly, re-riveting, re-inspection. It meant 4 hours lost, minimum. Ruth stepped forward, her instincts engaging before conscious thought. Her hands moved over the tool set, checking air pressure first. The gauge read 72 pounds, well below specification. She adjusted the compressor regulator, watched the needle climb to 90. The clock ticked. There was no time for formal work orders or engineering review. The pattern had to hold. If not, Station 7 would fall behind, and the ripple effect would cascade through final assembly. Ruth's focus narrowed. She removed 8 improperly seated rivets using a pneumatic chisel, careful not to damage the surrounding aluminum skin. Each rivet hole was inspected, deburred if necessary, then re-drilled to the next oversize if the hole had elongated. Standard Boeing procedure, documented in process specification BS427. She selected new rivets from the bin, AN47 AD6 aluminum alloy, 3/8 inch diameter. The task became almost rhythmic. Insert rivet, position bucking bar, trigger gun, check seating. Each rivet required 2.5 seconds of pressure. 12 rivets meant 30 seconds of continuous precision. "We can't afford another mistake like this," Holbrook muttered under his breath, but Ruth didn't respond. Her work would answer. She completed the repair in 11 minutes. The section passed inspection. The factory moved forward, but the incident left a residue of tension. One mistake, one moment of inattention, and the entire schedule could collapse. Records show that September 15th marked the first day Station 7 achieved 7.2 sections, above target for 3 consecutive shifts. On September 18, 1941, the line was pushing forward with new momentum. Ruth's rivet pattern had gained traction across wing assembly, and other workers were slowly learning to replicate her technique. Station 8 logged 6.4 sections, Station 9 reached 6.1. Yet the machines were still imperfect. There was strain in the system. Workers hustled, trying to match Ruth's meticulous approach, but fatigue was setting in. Third shift showed higher reject rates. "Not like that. You need to angle the gun," Ruth directed, her voice firm, her hand demonstrating the proper 45-degree approach on a curved surface. "The pressure needs to be even, constant. Don't pulse the trigger." She saw the wear in their eyes, the exhaustion that came from 10-hour shifts, 6 days a week. They were all feeling it. The weight of the task, the long hours, the sweat mixing with cutting oil and aluminum dust. Boeing had hired 3,000 new workers since June. Most had never touched a rivet gun before July. Training was abbreviated, on the job, learn by watching. Ruth had become an informal instructor, though her badge still read, Riveter, Grade 3. But Ruth was still there, guiding them through the mechanical choreography, one rivet at a time. With each successful wing, they were closer to arming the Air Corps. She didn't know exactly how it would unfold, but the factory's output mattered. Her eyes, unblinking despite fatigue, scanned the pattern again. Every piece of the assembly had to work in harmony. A letter from Boeing President Philip G. Johnson to War Department officials, dated September 20th and archived at the National Archives, notes, "Production efficiency in wing assembly has increased 23% since early September due to standardized techniques and worker cross-training." The letter doesn't mention Ruth by name. It doesn't mention Station 7 specifically, but the numbers reflect the change rippling through Plant 2. Ruth took a 10-minute break at 3 p.m., her first since shift start. She sat on a wooden bench near the tool crib, hands trembling slightly from vibration fatigue, and watched the line continue without her. It was working. The pattern was spreading. On September 20th, 1941, the line was measurably smoother. Ruth watched, her chest tightening with cautious pride, as the workers around her began to mirror her movements with increasing accuracy. The pattern was spreading, the seemingly impossible geometry that once only she could handle consistently. The sound of rivet guns was a symphony of synchronized precision. Each wing section slotted into assembly jigs with an ease that had been unthinkable 3 weeks earlier. Ruth stepped back, wiping her brow with a cloth kept tucked in her belt, and watched the assembly move like a well-calibrated system. Station 8 completed 7 sections. Station 9 reached 6.8. Station 10, newly configured, logged 5.9 on its second operational day. One of the foremen, Walter Pierce, approached with a look of cautious relief. "Ruth," he said, loud enough to be heard over the machinery, "I think you've cracked it." Ruth didn't respond immediately. Her eyes remained on the line, her mind still calculating, adjusting, anticipating the next potential failure point. The mission wasn't over. Not yet. Not until the aircraft rolled out of final. Assembly, engines installed, systems tested, paint dried. Pierce handed her a production summary sheet, the kind usually reserved for supervisors. The numbers were clear. Wing assembly had produced 41 sections on September 19th, 53 on September 20th. The target was 56. They were within statistical striking distance. "Keep it steady," Pierce added. "Front office is watching." Ruth nodded, understanding the implication. Executives were tracking the numbers. Army Air Corps liaison officers were filing reports. The pressure was shifting from survival to sustainability. Could they maintain this pace? Could they accelerate further? The B-17E was just one variant. Rumors circulated about a forthcoming F model with modified nose glazing. More changes meant more patterns, more training, more precision required. Ruth returned to Station 7, checked the jig alignment with a machinist square, and began the next section. The aluminum skin was cool to the touch despite the ambient heat. Late September sunlight slanted through the factory's high windows, illuminating metal dust suspended in air. The war was still far away, but here in Seattle it was being forged rivet by rivet. On September 22, 1941, success generated its own pressure. With increased production came exponentially greater demands. The War Department, sensing Boeing's capacity was rising, informally requested acceleration. 65 airframes by October 15th instead of 52 by October 1st. Ruth noticed the strain on the workers immediately. Tired eyes became red-rimmed. Hands began to shake during the last 2 hours of shift. Error rates, which had declined through mid-September, started ticking upward. "Can't keep up?" Riveter Martin Kowalski muttered during a brief pause, defeat edging into his voice. His station had rejected 2 sections that morning. Ruth didn't allow herself to show weakness or doubt. She stepped in again, correcting technique, adjusting templates, demonstrating the proper angle and pressure. The task was harder now. Volume was increasing, but so was fatigue. Holbrook added a 4th shift, experimental, running from midnight to 6 a.m., skeleton crew, minimal supervision. Quality suffered. Ruth volunteered for partial 4th shift coverage twice a week, arriving at 1 a.m. to troubleshoot problems that had accumulated during 3rd shift. The factory at night was different, darker despite floodlights, quieter in the spaces between machines, colder as autumn deepened. She worked by the illumination of task lights clamped to jig frames, shadows moving across aluminum like shifting blueprints. Other workers began to recognize her not just as skilled, but as indispensable. When Station 12 encountered a complex junction where 3 curved surfaces met at irregular angles, Ruth was called over. She studied the blueprint under a work light for 90 seconds, then demonstrated the approach. Start at the apex, work outward in spiral, pattern, maintain consistent pressure. The section passed. Boeing's internal memorandum from September 24th, preserved in company archives, notes, fatigue-related errors increasing, recommend rotation protocols and additional break periods, but rotation meant slower individual productivity. Breaks meant fewer rivets per shift. The tension between human endurance and production quotas was becoming acute. Ruth understood this tension in her shoulders, her lower back, the persistent ache in her right wrist from trigger pressure. She was 28 years old. She'd been at Boeing for 4 months. She felt older. On September 25, 1941, the test came at 10:23 a.m. without warning. Ruth was adjusting a rivet sequence on a particularly difficult compound curve when a loud screech echoed through wing assembly. The sound was wrong, metal grinding against metal, pressure escaping. The assembly line stuttered, slowed, then stopped. A rivet gun at Station 9 had jammed, its pneumatic mechanism frozen. The operator, a new hire named Davis, stood helpless, gun in hand. Ruth stepped forward, her palms sweaty despite the cool air, her heart rate accelerating. This was critical. The line couldn't afford extended downtime. Every minute of stoppage meant lost sections, lost airframes, lost time. The team looked to her. Holbrook was across the factory dealing with a parts delivery dispute. Pierce was in a production meeting. Ruth was the most experienced person in immediate proximity. She steadied herself and, with a calmness she barely felt, began to diagnose the problem. First, air pressure. The gauge read normal. Second, trigger mechanism. She dry-fired. The trigger moved freely. Third, rivet insertion pathway. She removed the retaining pin and extracted the jammed rivet. It was deformed. probably due to improper seating in the gun's nose. Metal shavings were visible in the mechanism. Ruth disassembled the gun methodically, laying parts on a clean cloth in sequence so reassembly would be straightforward. She cleaned the pathway with a wire brush and compressed air, checked the bucking bar interface, reassembled the gun. 3 minutes had elapsed. She selected a test rivet, positioned it, and fired. The gun responded correctly, driving the rivet cleanly. She glanced at Davis. "Check your rivets before loading. If one's bent, don't force it." Davis nodded, embarrassed, but learning. The line resumed. Pneumatic percussion filled the factory again. Ruth returned to Station 7, her hands trembling slightly from adrenaline. Holbrook appeared 10 minutes later, having heard about the stoppage and resolution. He said nothing, just nodded at Ruth, but his expression conveyed respect. The factory moved forward because she had acted without hesitation. Records show that September 25th's production reached 58 sections despite the interruption. On September 28, 1941, at 4:47 p.m., another wing section slid into place at final assembly. Ruth watched from wing assembly's observation area as the B-17E began to take recognizable shape. Fuselage, tail section, engines mounted on completed wings. The shift had been monumental over 3 weeks. Production had climbed from 43 assemblies per week to 61. Pierce approached with a production summary and a rare smile. "It's working, Ruth. You've done it." Ruth didn't say a word. Her heart pounded despite outward calm. This was validation, but it wasn't conclusion. They still had weeks of sustained effort before the October deadlines were secure. The aircraft taking shape in final assembly would carry 10 crew members, 13 machine guns, and 4,000 pounds of bombs. It would fly at 25,000 feet and survive what smaller aircraft couldn't. Ruth understood that her work wasn't just about rivets or patterns, it was about the mathematics of survival, structural integrity translated into lives preserved at altitude. A telegram from Army Air Corps Materiel Command to Boeing, dated September 29th and archived in War Department records, stated, "Production acceleration noted. Continue current tempo. Additional orders forthcoming." The telegram didn't mention individuals or specific innovations. It dealt in aggregate numbers and strategic requirements, but behind those numbers were people like Ruth, whose precision enabled the acceleration. She returned to Station 7 for the final hour of shift. Her hands moved automatically now, muscle memory guiding each motion. The learning curve had flattened. What had required intense concentration 3 weeks ago was now reflexive, but Ruth remained vigilant. Complacency bred errors. She'd seen it happen. Workers who grew too confident, who stopped checking measurements, who assumed rather than verified. Those workers produced rejects. Ruth never assumed. She measured, checked, verified. Every rivet, every section. By month's end, wing assembly had exceeded targets for 7 consecutive days. The compound curve pattern that had seemed impossible in early September was now standard procedure, taught to new hires as foundational technique. Ruth's innovation had become institutional knowledge, absorbed into Boeing's production process without fanfare or formal recognition. On October 1st, 1941, victory came with physical cost. Ruth felt it in her shoulders, her back, every bone in her body aching from sustained, repetitive motion. The relentless push for precision had extracted a toll measured in muscle fatigue and nerve strain. There was no time for rest, no time for recognition ceremonies or formal acknowledgement. Yet Ruth knew, with certainty that transcended exhaustion, that her work would outlast her physical presence. The factory would continue running long after she moved to another station or another role. But the wings she'd built, the techniques she'd refined, would carry forward. Medical records from Boeing's industrial clinic, reviewed by company historians decades later, show that repetitive strain injuries increased 18% during September and October 1941. Ruth visited the clinic twice in early October for wrist pain. The nurse recommended ice and reduced hours. Ruth declined the hour reduction. The targets mattered more than temporary discomfort. Production numbers for the week ending October 4th showed wing assembly completing 67 sections, the highest weekly total since Plant 2 opened. The B-17Es rolling out of final assembly were being ferried to Air Corps bases across the United States. March Field in California, Langley Field in Virginia, Hickam Field in Hawaii. Each aircraft represented collective effort, thousands of individual actions coordinated across dozens of stations. Ruth's contribution was one part of an immense system, but her part had been crucial during the bottleneck period when production threatened to collapse. On October 3rd, Ruth was reassigned to training duties 3 days per week, teaching new hires the wing pattern techniques she'd perfected. It was recognition without title change or pay increase. She accepted it without comment. Teaching was slower paced than production work, allowing her body some recovery. But it also meant watching others perform the work she'd mastered, watching them make mistakes she'd already solved. Patience was required. Ruth discovered she had reserves of patience she hadn't known existed. She could explain the same angle correction 5 times to 5 different workers without frustration. The mission demanded it. The war effort required not just her skill, but her ability to transfer that skill to others. On October 5th, 1941, the final wing section of B-17E, serial number 419032, clicked into place at 2:15 p.m. Ruth watched from the floor as the completed aircraft rolled toward the paint hangar, its bare aluminum skin gleaming under factory lights. The aircraft would be painted in olive drab and neutral grey, given final systems checks, and ferried to an operational unit within 10 days. The pattern that had seemed impossible in early September now carried the weight of tactical reality. This bomber would fly missions. Crews would trust their lives to the structural integrity of rivets Ruth had driven or techniques she had taught. That responsibility was profound but abstract. Ruth couldn't follow the aircraft to war. She could only ensure that every rivet met specification, that every joint held under stress. The mathematics of metal and force were knowable, controllable. The chaos of combat was not. Boeing's production records for October 1941 show that Plant 2 delivered 68 B-17Es, exceeding the revised contract target by 3 airframes. The acceleration from 43 per month in August to 68 in October represented a 58% increase in output without proportional increase in workforce. Efficiency gains, driven by standardized techniques and reduced rework, had made the difference. Ruth's contribution was documented only indirectly in station logs and supervisor notes. Her name appeared in no executive summaries or War Department reports. This was typical. Industrial production was measured in aggregate, in units delivered and contracts fulfilled. Individual contributions disappeared into collective achievement. But on the factory floor, among the workers who'd struggled with the compound curves and then mastered them, Ruth's role was understood. On October 8th, a small group of riveters presented her with a handmade insignia, a tiny B-17 silhouette riveted from scrap aluminum. No formal ceremony, just quiet acknowledgement during break period. Ruth accepted it without speech, nodding her thanks. She kept it in her toolbox, a tangible marker of intangible respect. The war was approaching. though no one at Boeing knew exactly when or how America would enter the conflict. Japan's ambitions in the Pacific were clear. Germany's advances in Europe were documented in newsreels. The B-17s leaving Plant 2 would matter soon. On October 10, 1941, Ruth stood at the edge of wing assembly during first shift, watching the pattern she'd established continue without her direct involvement. It was done. She was done with this phase. The war machine would move forward, absorbing her innovations as standard operating procedure. New workers arriving for training would learn the compound curve technique as foundational knowledge, unaware of its recent origin or the struggle required to develop it. The wings would continue to fly, carrying forward the story not of individual triumph but of collective industrial capacity. Boeing's production rate would continue climbing through 1941 and into 1942, eventually reaching peaks that seemed impossible from the perspective of September 1941. Ruth would be reassigned in November to a different section, then to quality control in early 1942, her trajectory through the factory following the typical pattern of skilled workers promoted to supervision and oversight. Her direct impact on production would diminish even as the production system she'd helped optimize continued expanding. A photograph exists in Boeing's corporate archives, dated October 1941, showing wing assembly at full operation. The image is black and white, slightly out of focus, taken from an elevated angle. Dozens of workers are visible, bent over jigs and assemblies, rivet guns in hand. Ruth is in the photograph, identifiable only if you know where to look. Fourth row, second station from left, partially obscured by a support column. She is working, head down, focused on the task before her. The photograph was taken for a War Department report on aircraft production capacity. It shows output, not individuals. Yet individuals made the output possible. Ruth understood this paradox. Her work mattered because it contributed to something larger than herself. Recognition was secondary to function. The B-17Es produced in September and October 1941 would see combat throughout the war. Some would be lost in the first months, others would survive dozens of missions. The aircraft that became most famous, Memphis Belle, Hell's Angels, were from later production runs, built using techniques established during this period of acceleration. The foundation Ruth helped create would support the entire wartime production surge that followed. On October 12, 1941, the factory was quieter than it had been in weeks. The emergency pressure had subsided following successful October delivery. Normal operational tempo resumed, still demanding, still urgent, but no longer crisis mode. Ruth's mind was still racing despite the eased pace. She reflected on what had been built during the previous 6 weeks. Not just aircraft components, but the legacy of the workers who'd persevered beside her. She looked at the B-17 taxiing on Boeing Field outside the factory windows, and knew, with certainty beyond documentation, that the war effort had forever changed. And so had she. She was no longer the new hire feeling uncertain about her place in industrial production. She was a skilled worker whose expertise had been tested and validated under pressure. That knowledge would carry forward regardless of where Boeing assigned her next or what role she filled. The pattern she'd mastered, the techniques she'd refined, the training she'd provided, these contributions would ripple through thousands of aircraft and years of production. Ruth Erickson's personnel file, preserved in Boeing's historical records, shows her employment continuing through 1945. She worked in quality control, then training coordination, then production scheduling. She received 2 pay increases and 1 commendation letter. She left Boeing in October 1945, shortly after Japan's surrender, part of the massive industrial demobilization that followed war's end. Her file contains no mention of the September 1941 production crisis or her role in resolving it. That story lived in station logs and supervisor memories, not in official records. Decades later, when historians began documenting the industrial contributions of workers during World War II, Ruth's name emerged in interviews and archive research. She was located in 1983, living in Tacoma, and interviewed for an oral history project. She was 70 years old. She remembered the compound curve pattern, the pressure, the exhaustion. She also remembered the satisfaction of solving a problem that had threatened to derail production. "We just did what needed doing," she said in the interview. Everyone did. The file closed without additional comment. The numbers had already told the story.